Hey, I'm going to share our story, how we built data science in a year and achieved 8-digit impact business-wise. But first, I'll tell you why ride-hailing is a business at all. Why should you pay attention? So here's the growth of the company in the number of rides. What's notable here is that when Daimler joined us as investor in May, we had just 50 engineers. This means that a lot of effort goes into automation and using what's available. We build on top of Amazon Cloud, etc. We use technologies where we can build only what we must. And in the early days, you didn't need data science. Simple heuristics, rules, these did the wonders. But as you scale, you need applied math, statistics, models, and I'll be sharing how to get them live in a year. So Taxify is a ride-hailing company focused on Europe and Africa. And we think the winners are local. We have seen that in China with Didi, in Russia with Yandex, and we focus in Europe and Africa, where we are either number 1 or number 2 in the cities we operate in. So the models we build are also very city-specific. So we put a lot of context about the city into the models we have. And on this slide, that tells everything. So how Taxify business works, why it matters. It has network effects within cities. As we get more drivers on the streets, the service gets better, cars arrive faster, people want to ride more, higher earnings for the drivers, and this leads to lower prices. And the main difference between Taxify and others is that we offer better earnings to the drivers, and we use machine learning to do that as well. Right now, it's a small fraction of all the urban mobility. Just 3% of all city transport happens with on-demand, with scooters, with cars, with bikes, all forms of vehicles that we have in the system. But we think it's going to change. And why is it changing? It's because of micro-mobility, pooling, and in Western developed countries will get self-driving. Many companies have recognized this. What is Taxify focus? We don't build our own robots. We partner with companies who do. But we focus on optimizing the city, making sure that the rider gets the right vehicle when they need it within 3 minutes. And we aim to do so in Europe and Africa. Okay, now about data science and how to use it. Here is Taxify product in layers. Any system is built of layers. What users experience is mostly the mobile app, the user experience there. Some users get their rides via Google Maps, for example, where you can get the ride, and of course, users will experience the self-driving vehicles. Then the next layer is when something happens, an incident, you forget the scarf in a car, the customer support helps you. Payments, fully automated process, we need to monitor the fraudsters so that the payment quality is good. And then the onboarding of drivers, we have 500,000 of them right now, so it's quite a lot of effort to train them, to onboard them, to keep them. But the core of our focus in data science is in transport layer, in pricing, and campaigns. This means real-time price for such that the driver will accept it and the rider will not cancel. Campaigns, this means what bonus to give to what driver, what discount to give to a rider so that we grow fast. We have to do these pricing and campaigns not only for a day, but for a week, for a month, for a year. So there is a long-term perspective in these models. And then there is, of course, the transport aspect. So how long does it take for a car to drive? What's the traffic, etc.? And the company is very data-driven in all these areas, so many decisions made based on data. I'll skip the lower levels, but of course we build on existing technologies. You open up, you see Google Maps. We are on AWS. We collaborate with Microsoft. And the security and compliance by the governments, these are what define what we can do. Okay, so the data science process itself, it's very similar to what any company experiences. We have to collect the data, clean it, transform it, find the patterns. Once we find the patterns, we put them into the models, we push them to production, and the cycle continues. We are a small team, so we focus a lot on automation. We've used automated machine learning for a year already, and we automate many different parts of the system as we go. I'll skip the decision-making part because I'm focused on the automated decision-making at the moment. If you compare Taxify to other companies, so what's the status with machine learning adoption globally? Most of the companies are still exploring. They haven't recognized the value of machine learning and data science. The early adopters have recognized this, are moving forward fast, so we're catching up with Didi and Uber, who have 100 times more data scientists and are a bit ahead, but we are catching up really fast. And why we can do that is because we build on existing technologies. We don't need to build everything on our own. And I think this is a valuable piece. So I will not tell you about the challenges of doing data science. Instead, what I'm sharing with you is how we solve those challenges. And these are two really simple ideas. One is Kaizen, meaning continuous improvement. And the second is being nimble. So, of course, you want to make sure you are solving the right problem, that you're measuring the right metrics, that you are having impact. So you have methods for that. Since it's R&D and there is uncertainty, you time box and scope those efforts so that you continuously move and are able to change directions fast. A small team needs great tools, so that's what we give our engineers and data scientists. For example, we cannot test everything in live, so that's why we have a simulator. So we can play through a city 100 times faster, see the results of algorithm change, and only then deploy it to the city. The design of experiments and A/B tests, it's an art, but it's an art that has been made better and better for already 100 years. So we design our experiments also in a way so that they produce statistically significant results. And of course, as any other engineering, you do the reviews, etc. Doing data science is not a solo effort, it's a team effort. So you have to have clarity in roles. What are engineers doing, scaling the system, etc. Data scientists doing feature engineering, model tuning, method selection, etc. Product manager works with data scientists to understand the why part. Engineer works with data scientists to understand the how part. And in our company, data scientists work in virtual teams, and data science itself is a function. This is another slide telling you the same product functions that you saw before in layers. These are the engineering challenges, topics we solve. And I think one of the most interesting pieces in our industry is that we have city geography and time. So Mondays are different from weekends in terms of demand. City centers different from suburbs. So there is a lot of algorithmic challenges that stem from it. All the rest I already shared, I'll skip it, but the point is that we develop many models, including with automated machine learning, and we then select the best model with the best performance and release it, A/B test it. If it performs, we scale it. Many decisions need to be made as engineers, and here's how we make them. It's quite common method. So what we do is we try to reduce the greatest risk for the lowest cost, because that allows us to move fast. In essence, example here would be that we are using a data provider. If their data is wrong, our models will produce wrong output, so it's a high risk, very easy to validate, so we have a layer of tests for that. So to summarize, in Kaizen spirit, this is how we do data science at Taxify, and this is how we have achieved real business results. So we build, we measure, we learn in really fast and small iterations, continuously changing direction, and this allows us to move fast and in the right direction. So that's it. Thank you.
Okay, do we have any questions up here for André? Oh, we have one there. We're getting you a microphone.
So a question about to what extent do you automate the machine learning? Do you use something like Amazon machine learning where everything is automated? How much code do your data scientists write themselves?
Yeah, so what we do is machine learning, simulation, econometrics, operations research, etc. When it comes to code, we write it together with the engineer. We use, for example, we use Amazon SageMaker for machine learning in production. We have our feature stores, we have our data collection and indexes. All this infra is being built. In March, on 7th of March, at North Star AI conference, we'll introduce our machine learning platform a bit more broadly. There you will see what pieces of it are automated to what extent. So we are a small team, I mean, less than 100 engineers. So we compete with giants day to day. So we better make sure we spend time on high value engineering efforts. So we try to automate as much as we can.
Nice. Down the front here. Oh, sorry, so pardon me. Sorry, so go ahead.
So do you automate, I mean, do you A/B test your business models as well? Like different practices, how to get clients, the payment systems, you know? Do you A/B test your biz dev basically? And when you do tests, how do you decide that this approach has failed? What's the point?
So with A/B, it's quite simple. You don't need to A/B common sense. So you don't A/B things you are sure that will work. In areas where you have higher uncertainties, you do the tests, right? So, yeah.
I mean, if you have like two competing business models, or like little pieces of a business model, do you test that, or you just apply common sense to that?
So we have an engineering blog, by the way, where we write all the details about this, and also about the Kaizen method. We wrote a piece about pricing, for example, how we develop pricing. You can read there all the details. There are many layers to pricing. We test each layer, each component change, make sure that it works in a city, and only then use it. So it's a continuous process. There is no waterfall.
I mean, like, are you talking about the engineering approach or the business approach? Because my question is about the business side.
What's the difference?
I mean, if you're testing out new ideas, like, like, when do you know the idea has failed? Because it's not evident when you're in there. It's evident like a year later, maybe. Oh
yeah, you look at in A/B. You look at whether the test produces statistically significant results. If it doesn't, you move on. So if you're looking for long-term effects, then the PMs, the engineers, they are monitoring the trends in the data, right? So there is some intuition that has to go into, but some trends machines can help us find. It's a continuous effort. So city teams make many decisions all the time to be able to grow fast and offer the service the users need. So our company moves really fast, changes direction really fast.
All right, maybe we should take this one offline afterwards. We'll just move on. We have one more question down here. We do need to move on. Thank you.
Hi, my name is Vishal. I'm from India. I would like to know that which are your countries of interest going forward, maybe next 3 years?
Next 3 years.
Yeah, sure.
Okay, yeah. You saw the map. So our home market is Europe and Africa. We want to grow. In Africa, we think we will grow tenfold.
Okay, so looking to dig yourself into your existing markets is where you're going with this. All right, we're going to wrap it up there. Please, one more round of applause for André. Thank you.
So